Welcome to our first video in the calculus course that will go through how to differentiate the first of the transcendental functions, which in this video we'll talk about inverse trig functions and how to do their derivatives. Transcendentals is kind of a general term that describes functions that can't be expressed just using variables and exponents. So things like logarithms, trig functions, which we've already done, exponentials, inverse trig, as I mentioned, and that's where we're going to start. So inverse trig functions, just to refresh your memory on the notation of them, there's two ways you'll see inverse trig functions written, either as sine to the exponent -1, which means inverse sine, or you may see the word arc written below, referring to arc functions. So we should at this point know what an inverse trig function means. So again, I'm not teaching you inverse trig functions, I'm teaching you how to take the derivative of them. So this would be some information which hopefully have a bit of prerequisite knowledge of. This would mean angle y is an angle whose sine ratio would be equal to x. So for example, if we were to see inverse sine of a half, this would be saying find the angle whose sine ratio is equal to a half. Now we should be able to represent inverse trig functions visually. So for example, if I said y equals inverse sine of x. So remember, y is an angle whose sine ratio is x. So sine is opposite over hypotenuse, so x over 1 would give me a sine ratio of x, which would mean I could then get the third side in this situation, which would have to be 1 minus x squared, take the square root of it, using Pythagoras theorem. So for example, it says represent the inverse trig function of y equals inverse secant 3x squared with a diagram. Get this out of my way. Why is this all grouped together? Anyway, let's do this top one. There's two questions jammed together here. Alright, so I want to draw an angle y whose secant ratio is 3x squared. So secant, right? The secant of an angle is the hypotenuse over the adjacent. It's the reciprocal of cosine, so the hypotenuse over the adjacent is in the ratio of 3x squared over 1. So the hypotenuse would have to be 3x squared, the adjacent would be 1. We then use Pythagoras theorem to get the third side in our diagram. So the third side here would be the hypotenuse squared, 9x to the 4th. Subtract your other side squared, which is a 1. So then, oh, now I see why the two are together. So now it's saying find the tangent of this angle. So this angle we sketched on here, we've called it angle y. Maybe it would have been better to call this theta, just so it's less confusing. The problem is I have y being two different things here. So let's say this is theta. So this is basically now saying find the tangent of the angle that we've described up above. So you look at your diagram, you say, well, the tangent would be opposite over adjacent, opposite over adjacent. So this would be equal to the square root of 9x to the 4th minus 1 over 1. Okay, let's do, oops. I don't want that on this side. Okay, this one says find the cosine of the inverse cosecant. So remember, inverse trig ratios are angles. So let's sketch this angle. It's an angle whose cosecant ratio, which is hypotenuse over, so this being the ratio of root 5 over x over 1. So that must be 1. And then I use Pythagoras to find my missing side. So when I square radical 5x, it's 5x minus the other side squared. Take the square root of it. There's your other side. and this asked us to find the cosine. So cosine would equal the square root of 5x minus 1 over the square root of 5x, which can actually be written as square root 5x onto 5x minus 1. If you rationalize the denominator, you get that. Rationalize the denominator by multiplying by square root 5x over the square root of 5x, and it'll give us that. That is the cosine off of that diagram. I might have one more of those. Let's say, okay, well, how does that help me? Well, I should give you one where it doesn't have to be a 1 here. Let's just do one, maybe freehand one here I'll make up. Let's do the secant of the inverse cosine of x cubed over 3. So now that means that on my diagram, remember this is your angle, so I've got some angle, theta, whose cosine is x cubed over 3. So cosine is adjacent over hypotenuse. Pythagoras' theorem would say that this side then is 9 minus x to the 6th. So then if I want the secant of this angle that was described, so secant would be 3 over x cubed. That wasn't a great one to pick, but it's good to, I guess, practice drawing it, but nope, cubed, not squared. Secant is hypotenuse over adjacent. Okay, so how does that translate into calculus and finding the derivatives of inverse trig functions? Well, what we would do here is, because we don't know how to find the derivative of an inverse trig function yet, we would switch it to something we do know how to find the derivative of, which would be trig ratios, primaries and reciprocal trig ratios. So I know that based on this, the cosine of angle y has to equal 2x squared. That's what this means. Well, using implicit differentiation, we just go left to right. So the derivative of cosine u, that's an earlier derivative rule we've already learned. Cosine u is negative sine u times the derivative of u. Take the derivative of the right side, 4x. So I'm trying to solve for derivative. So dy dx is 4x over the negative sine of y. Well, the problem here is that the original function is what we call an explicit function, meaning it's got y equals, or f of x equals isolated, and then your function of x on the other side. Unfortunately, the answer I'm giving is implicit, which I can't do. I can't start with an explicit function and give an implicit derivative. So what I need to do is somehow be able to come up with an expression in terms of x for the sine of y. So what we're going to do is we're going to draw angle y. So angle y, right? This is an angle whose cosine is 2x squared over 1. Use Pythagoras to get your missing side, 1 minus 4x to the 4th. So then off of this diagram, I should be able to fill in here the sine of y. So the sine of y, so sine of y off of that diagram, dy dx, which is what I'm looking for, is 4x over negative. The sine of y is opposite over hypotenuse, so it is square root 1 minus 4x to the 4th. Now, all of these steps where you're seeing here, obviously I want you to understand where they came from, but I'm going to show you here in a moment just a chart, and we're going to look at the inverse trig function and we're going to write down a rule. So there's a pattern here that I'd like you to try and find. So I'm just going to write it out this way. So dy dx is negative 4x over the, so I've just taken that negative, pushed it to the numerator, 1 minus 2x squared squared. So the original function was y equals inverse cosine of 2x squared, and this is its derivative. And we want to get to the point where we skip all this work and we simply do this. Now, I didn't want to start out by showing you that because that doesn't give you the chance to really understand where these rules came from. So let's do maybe, oh, I thought I had one more that way. Maybe it's underneath here. All right, here it is. So let's find this one. Inverse cosine of root x. So, same thing. What I know is that the cosine of angle y must be the square root of x. That's what this means. Take the derivative of cos, which is negative sine of u. Differentiate your u. Differentiate this with power rule, 1/2 x to the negative a half. Now I want to get derivative, which is dy dx by itself. So I've got 1/2 x to the negative a half over the negative sine of y. Well, I need to come up with sine of y, so I would draw a diagram. Angle y, what I knew in the beginning was its cosine, I believe, was root x. So the cosine, which would be adjacent over hypotenuse, this side would have to be 1 minus x. So my derivative, dy dx, would be 1/2 x to the negative a half. I'm just going to put my negative up there. And sine of y, I look at my diagram, opposite over hypotenuse is the square root of 1 minus x. So my original function was inverse cosine of radical x. And we can see that the answer is negative 1/2 x to the negative a half over the square root of 1 minus x. This would be negative 1/2 x to the negative a half over the square root of 1 minus root x squared. So what I would ask you now is, after looking at these two examples, have you noticed a pattern that you think you would be able to now tell me if I said to you y is just equal to the inverse cosine of u, which is a notation we've used earlier with the regular trig functions. U is just some differentiable function. Do you see a pattern here that you could say y prime is? Well, if you look at the two examples, the numerator is the derivative of the original argument, u, in both cases, right? There's your du. We do end up with a negative of it, so I'm going to write this as negative du. And notice the denominator in both of these cases is 1 minus the square root of your original argument. So 1 minus, in this case, root x squared, which gave me just x. And here, it was 2x squared, and you'll notice we ended up with 4x to the fourth, which was my original argument, squared. So the pattern for inverse cosine will always turn out to be negative du over the square root of 1 minus u squared. So what that means is if I have y equals inverse cos of 5x to the third, okay, we don't go through all that work anymore. We now rely upon this shortcut and we say, well, y prime must be negative du 15x squared over square root 1 minus u squared, which would be 25x to the sixth. Now, I've done just inverse cosine. I could do the exact same process for all of the other 5 inverse trig functions, and a similar pattern would pop out of each one. Now, it's not the exact same. They each have their own rule. So what I have for you is a chart now that, oh, where's my chart? Here it is. A chart for you that outlines all of the 6 inverse trig functions and their derivatives. So you're going to want to jot these down so you have them, and you are responsible to know these, so they're not provided, you have to know them. And these are the 6 rules to differentiate your inverse trig functions. So you probably want to pause the video here for a moment, and as I said, jot these down. I'll just get you to note a couple of things. There are 3 of them that have the negative. Now you'll see that I have the du off to the side in these. which is the same thing as having it up above. It just depends. Sometimes the du, if it's just a 2x or 5x, I just put it up here. But maybe if the du is something that's more elaborate, I might put it out beside it just so that I don't get fractions within another fraction and make it look like a kind of a real mess algebraically. There are the three negative ones, as I was pointing out. I'll highlight them here for you. Negative. There's another negative one there, and there's a negative one there. And it should not surprise you if you learned your differentiation rules for regular trig functions that your inverse trig functions that are negative are also the ones that start with the letter C. Inverse cosine, inverse cosecant, and inverse cotangent. You should also notice that sine and cosine are the exact same pattern except cosine is negative. Tangent and inverse cotangent, exact same pattern except inverse cotan is negative. And cosecant and secant also, that's the exact same pattern, and one of them, the cosecant is negative and your secant is positive. So if we just wanted to quickly look at a couple of examples of this, I think my page has got a little order on me here. Let's go back here to this one. So if I wanted to find the derivative of this, well, the first thing I look at and say, okay, this is a chain rule. Sorry, not a chain. Well, it's going to be a chain rule, but it's a quotient rule first. So I have a quotient. So quotient rule says to take the derivative of the numerator. We've done this last semester earlier on where we did our rules of differentiation. Cotan 5x cubed. So that is a chain rule. So I'm going to take the derivative of the numerator. Now this is a regular trig function, not an inverse trig function, but it's still considered a transcendental. And the rule in this case would go 3 cotangent 5x, take one off your exponent, take the derivative inside the brackets, it's negative cosecant squared 5x times 5. That's derivative of the numerator. Multiply that by the denominator. Now you have to make sure you realize that the exponent -1 is not the same as any other exponent. It's not a chain rule. So this one indicates it's a symbol, it means inverse, so make sure you treat it properly. Subtract the numerator, which is your cotangent cubed 5x, and now I'll put in red again my derivative of the denominator. So the denominator is inverse trig, so inverse cotangent. The rule for inverse cotangent is negative du. So negative du over 1 plus u squared. So there's your 1 plus u squared. And then all of this would get divided by the denominator squared. So there's our quotient rule using some transcendentals. So I had to use a regular, well, I had to use chain rule first, and then I had to use my derivative of cotan. And then I had to do derivative of inverse cotan over here to get my derivative of the denominator. I think let's just jump ahead here a second. Okay, here's another one here. So this one is a product rule. Right, you have x cubed, which is a function, multiplied by inverse sine of 3x squared, which is also a function. So my derivative would be product rule, derivative of the first, multiplied by the second, plus the first, multiplied by derivative of the second. So this is inverse sine. So the rule for inverse sine. Now you'll notice I'm not looking these up on a page or anything. You have to eventually get to the point where you know these off the top of your head. You'll quickly find out this semester that if you don't know these rules, you're going to be in for a lot of difficulties when we get into integration. So the sooner you get these memorized, the better you are. So inverse sine, the rule is du over square root 1 minus u squared. So this is your u. So it would be du 6x over the square root of 1 minus u squared So 9x to the fourth. And that would be your derivative of your second. So derivative of the first times the second plus the first multiplied by derivative of the second. Product rule. Last one I'll do. So this one is a chain rule, and inside this chain rule we will have an inverse trig function. So f prime of x will be 1/2 3x minus the inverse tan of root x to the negative 1/2, right? It was 1/2. Now I got to multiply by the derivative inside the brackets. So 3x is 3 minus inverse tan is du 1/2 x to the negative 1/2 over no square root, it's 1. It is 1 plus u squared, u being root x will just give me 1 plus x. There's the derivative inside the brackets. Alright, so when we get to this second portion of our studies in calculus, we do make the assumption you've mastered your basic skills of differentiation. We'll just throw some more functions into the mixture in this first section, and we refer to those, as I said earlier, transcendental. So there's your first look at inverse trig functions and how to do their derivatives. So there will be some practice questions to follow. Hopefully this video can clear up any issues you may have, and if you do have things you don't understand, please reach out sooner rather than later. Thanks for watching.